Hello, class. Welcome to 1.3 Exponent Properties and Rules. Today, we're going to take a look at a couple of the different things we can do with exponents. But before we get started, let's talk about what an exponent is. An exponent consists of two parts, the base and the exponent. The base is going to tell us what number is to be multiplied, and the exponent is going to tell us how many times. So in this case, you see a 4, and you see the exponent is 3. So the exponent is going to tell us we need to multiply that 4 3 times. And if we multiply that out, you can see that 4 times 4 times 4 is equal to 64. So what we're going to use is our basic knowledge of exponents to walk through a few different properties and discover the shortcuts to them. Let's take a look at example 1 here with the multiplication properties. When we look at 12 to the 4th times 12 to the 3rd, what we really want to look at is, based on what we know about exponents, is 12 to the 4th really means we are writing that 4 times. And the times of 12 to the 3rd means we're going to multiply it by 12 3 more times. And really, we don't always want to take the time to have to write all them out. And if we try to convert this back into an exponent, well, now we have a total of 7 of them. So if we are looking at 12 to the 7th, that would be the equivalent form of the 12 to the 4th times 12 to the 3rd. So really, when you look at these, the multiplication property is simply going to be to add your exponents. Just like you did in, we're talking about in that discovery activity. Let's take a look at the x times x to the 5th. Once again, you could try to write them out and basically state that x times x to the 5th, well, that means we need to write it 5 more times. 4 and 5. Well, how many total is that? 1, 2, 3, 4, 5, 6. So we could say that that is x to the 6th. Now, again, we don't want to take the time to have to do that every time. So we could simply simplify that as our multiplication property with the same base is to simply add your exponents. If we look at example 2, the division properties, what we're going to be looking at with dividing is we are going to be subtracting exponents. So if you look at 5 to the 3rd over 5 to the 7th, if you think about what that really means, 5 3 times in the numerator, and if we have 5 7 times in the denominator, 1, 2, 3, 4, 5, missing 1. Well, what's really going to happen here? If we kind of use our cancellation, what that's going to leave us with is 1 over 5 to the 4th, which again we could a little bit simpler do by just saying, well, 7 and 3, 7 minus 3 equals 4. If we're going to look at example 2, again, making sure we have the same base. We don't necessarily want to take the time to write out all of our x's. But if we look at our 7 minus 2, now the 7, the larger number, is in the numerator here. So 7 minus 2 is simply going to be x to the 5th. In example 3, if we are seeing exponents raised to an exponent, once again, we need to make sure that these have the same bases, but you're simply going to multiply. So if we say 3 to the 6th to 3 to the 3rd, what we are looking to do here is going to be 3 times 6, which is going to make our exponent 3 to the 18th. This definitely beats the fact, if you think about what this really means, 3 to the 6 times 3 to the 6 3 times. And then we would have to expand all of these 3's 6 more times, which is going to be a lot easier if we just multiply those exponents. Now, the second example here, We got to be a little bit more careful. We look at all of these numbers with different bases. Well, that doesn't allow us to do anything with multiplying like we did in our previous examples. But the one thing we need to make sure of is if we have these different bases to an exponent, we need to make sure that this to the third power gets distributed to all of them. So the first one we're looking at there would equal 2 to the 2 times 3, that's 6, times 3 to the 4 times the fourth power, so that'd be 4 times 3 is 12. And if we look at 5 squared, well, 2 times 3 would be 5 to the sixth. Looking at these two special cases here, our 0 and negative exponents, what we're going to look at is anything to the 0 power is automatically going to equal 1. And if we look at anything to a negative exponent, okay, say x to the negative 2, the negative exponent is simply going to tell us to rewrite in the opposite. If it was 1 over x to the negative 2, it would bring it back to the positive. So negative exponent essentially means it's in the wrong place of the fraction. So looking at two examples, negative 3 to the 0, well, anything to the 0 power simply equals 1. That easy. If we're looking at the second one, well, what do we have here? We got a 5, nothing going on. A to the third, nothing going on. But that negative exponent is essentially telling us that that b really belongs in the denominator spot. Okay, class, that wraps up our knowledge of exponents and the properties and rules we can use. So use that to finish practice 1.3a. Simplify all 6 of those and move on with the rest of your assignments for the day. Thank you. Have a great day.